Bivariate data. Bivariate data refers to data that involves two variables for each observation, where the goal is often to explore whether a relationship exists between them. For example, a person's height and weight. For each person in the study, you're going to take two measurements, height and weight, the number of hours studied, and the exam score. Two linked measurements for each subject means that we have bivariate data. The correlation coefficient, written as R, is a number that tells us how strong and in what direction a linear relationship is between two variables. If R is equal to 1, we have perfect positive linear relationship. And when we say positive, it means the gradient is positive. So as one variable increases, so does the other. R equals 1, as it says here, is a perfect relationship, so all the points will lie on the line. We'll have a look at this again in a moment. If R is -1, we have a perfect negative linear relationship. So in this case, the gradient is negative, and as one variable increases, the other decreases. If R equals 0, there is no linear relationship. R is always going to lie between -1 and 1. Some pictures here give you an idea. Here we have perfect positive, so as we said before, every point is going to lie on a line. Here's a strong positive, R is equal to 0.8. We can see that the points line up along a line with a positive gradient, and they're reasonably close to it. This one is a much weaker positive relationship. We can still see that the data slopes upwards, but it's more like a cloud. It's further away from the line. Here's a weak negative with -0.4, and the same comment for over here, but this time with a negative gradient. Here we have strong negative, R is equal to -0.8. We can see the points lining up along or around a line with a negative gradient, and then perfect negative where everything is in a straight line but with a negative gradient. It is important to note that a strong correlation does not mean that one thing causes the other. It may or may not. This is often stated as correlation does not imply causation.